Somebody volunteered.
The heat capacity of 1 kilogram of water is 4,186 joules per Kelvin.
Per Kelvin.
What is the temperature change of water if 505 joules of heat is added to the system?
What are we looking for? Good. What are we given? Heat capacity, big C or tiny c? Big C. And we are also given heat and mass. Can I find delta T? Is there an expression we've done?
Yes.
Say this one. So that was C equals Q over delta T. So I'm looking for delta T. Yay. Number 2. Wait, you guys have an answer for me? 0.121. Excellent. Otherwise, I would have gotten this now. It would be your fault. Okay, next question.
Heated from 10 degrees Celsius to boiling 100 degrees Celsius. Specific heat capacity of water is 4.186 joules per gram Celsius. Find the heat required for this process.
Okay, be very careful. Here's how I remember it. If I look at this unit, guys, can we all look up? It's joule per Kelvin. Yeah? Look at this unit. Gram degrees. So in this case, which are they giving us? Small c. No. The difference is just the mass. Yeah. So they could give you the question in calc. Remember what we said when we were defining this? Where I wrote this definition? Do you now realize why this definition is so ambiguous? Yeah. Because it could be any degree, any measurement, except usually they give you per one, whatever that degree is. So you have to be careful about that number that they give you.
It's kind of gross.
Yeah. It's because it's against our understanding of the world. We want to know and we want it to be standardized. But when you have to understand when this was happening, they didn't even know what these things were. So, and people were working in silos and they weren't really talking to each other. So they did not standardize anything.
But now we know. Like, can we just standardize it?
Do you have a question? Yes, we do live in a world where 1 liter of water is a kilogram. And we should know that 1 liter of water is a kilogram. Yes. Where we can, let's convert to SI units.
Yay.
Except they now are going to confuse us because they're giving us grams. Yeah. So make sure that you have your masses all in the same unit so units can cancel out. Okay. So what are we given? We have a C that's 4.186 joules per gram degrees. 1 liter of water is equal to, what did you say, 1 kilogram? Or 1,000 grams? You could either convert this to kilograms or you could convert that to grams, whichever one you want. I don't have don't have a preference. Okay, and what is the delta T? Yep. Degrees Celsius, which is why this would be perfectly reasonable. If this was Kelvin, then we would have to convert that to Kelvin. And what formula should we use? What are we looking for? Heat required. M little c delta T. Yay. Can life get any simpler? It's like this is like the simplest thing. Okay, now very good. This is now water and a can with an initial temperature of 15. And now we have to find the final temperature of the system. So the system consists of two things. How did we say we deal with two things? What do we do? Split them up. How do we split them up? Delta Q for one, delta Q for the other one. And then add the system back together. And conservation of energy says total dQ should equal 0. So then you should have a W for water and W for the can should equal 0. And what is W? What is Q? MC delta T plus M little c, right? These are all little c's. Delta T equals 0. This would be for W, W, A. Do they give us all the values? And what is delta T? T final minus T initial. Do they give us T initials for both? Will the final temperature be the same for both? Can we plug numbers in? Done.